This homework requires you to build a simulator for a queuing system in an OS. As it says in the introduction, we will create a program to implement a basic scheduling system. The program will need to calculate waiting time, start time, and end time of each process. This project can be split into three main parts: the process, the server, and the waiting queue. Each process has an execution time. The execution time dictates how many seconds a process is to stay in a server. Once a process's execution time reaches 0, it is removed from the server and put into an array of completed processes. Each process starts its journey in the waiting queue, then gets added to each available server. Each server can hold one process at a time. As mentioned before, every second a process is inside the server, it gets a second removed from its total execution time. However, the servers have a max execution time. In this example, the max execution time for these particular servers is 2 seconds. Once a process has been in the server for more than 2 seconds and its execution time is greater than 0, it gets placed back into the waiting queue it came from. This continues until all of the processes are in the completed array. To start off, we're going to import all of the input files and the argument manager, and then write the boilerplate for argument manager. Next, we'll implement the process class, which includes members in server, which is a Boolean that keeps track of whether a process is inside of a server or not. A name, the execution time. At one point, I put original execution time because we decrement the execution time, so I wanted to keep track of the original execution time. Well, you can just grab that from the input file, so you don't really need that. We also have started time. So this is a Boolean that keeps track of whether or not it was given a started time. So because the process can be added to the waiting queue again, it may get assigned a new starting time. So we don't want it to get assigned a new time. So we have a Boolean there that keeps track of whether it was already assigned or not. And then finally, we have the wait time and the end time. And next we can implement all of our accessors and mutators for each of our members. So the setter for set start time is a little different because we only want it to get set once. So I have this condition here that makes sure that it only gets set once, and that if the set start time is called again, that it won't change the original start time. Now I'll run the code and check for any syntax errors and fix those. Now we'll implement the server class, which includes the member's name, max time, which will hold the maximum time given by the input file, secproc, which stands for seconds processed. So that's going to keep track of the seconds processed for one particular process. Busy, Boolean keeps track of the server is busy or not. Process time, and then finally process CU, which is the current process that is inside of the server. So after we implement the accessors and mutators in the constructor, we can implement our main useful methods, which first is return process, which returns the current process that is inside the server. Is finished, which returns a Boolean of whether or not a particular process is done or not. Start process, which passes in by reference a process and the time that it was started. So this sets the current process of the server as whatever you pass in, and then sets its execution time. And then finally, processing. This gets ran every iteration or every second that passes, and it increments the processing time as well as checks if it was finished that process or not. The last class we'll implement is the queue class. So in this homework, you have to implement it manually. So the members are a process array of processes. So originally I had done a dynamic array, but I was having segmentation faults and leaky code. So I just decided to make it arbitrarily large, and it works fine. Ideally, you should do a dynamic array, so you don't have to worry about the size. And then obviously we set the front end capacity and size. Additionally, we have to add our own special function that's not a part of the default ADT functions of a queue, and that's incrementing the waiting time. So we'll call this every second of the simulation, and what it does is for every process that is still in the waiting queue, add 1 to its waiting time. Now that we've defined all of our classes, we can now start reading from input. So as you can see in the text file, the first row of input tells us the max time for the servers, the total amount of processes, and the amount of servers we are to have. The next row tells us the execution time for each process. So because the input file tells us there are 3 processes, there are 3 execution times on the second row. Next, we'll create a server array that will hold all of our server objects. Use a for loop to initialize all of the values in the array. Then we'll create a process queue. And then finally, we'll read the second row from input. Now we'll create the clock and have variable I keep track of each second in time. We use a while loop for the simulation because the simulation doesn't finish until the completed size of the array matches the total processes. So in this test case, there are 3 processes. So once the completed size equals 3, then it'll stop the simulation. So at each moment in time, the first thing we want to do is check and update the processes that are currently in the server. So when time is equal to 0, there's going to be no processes in the server, so that this part's going to get skipped at the first iteration. When there is a process in the server, we're going to use an if statement here that is going to check what the processing method returned and then see if it's finished. And if it's finished and it returned the process, that means that it's completely done, and we should move it to the completed array. If the processing method returns true, but the isFinish method returns false, meaning that the particular process reached its max time, we're going to remove it from the server and then add it back to the waiting queue. So the last thing we do at each moment in time is add a process to a server if a server is available. So to help us do that, I'm going to create a function called rServerIsFull. and it'll return true if all the servers are full, meaning no more can be added. So this while loop here iterates through every server in the server array and then sets the next server index to whatever the index of the next available server is. We then add it to the server and pop it from the queue. We also increment the waiting time of each process in the queue if there's any still in there. The final part is outputting. According to the homework, you're supposed to output to a file, but for this video, I'm just going to output to standard out. Let's compile and run the code and see what kind of output it gives us. As you can see here, it gives us some information about each of the processes, its execution time, how long it had to wait, and when it started and when it ended.